Hey everyone, and welcome to today's Explainer. Today, we're going to be looking at something that is absolutely foundational, but honestly, it gets wonderfully overlooked all the time. Think about it. Most of us use a computer every single day, right? But very, very few people actually understand how they truly work under the hood. And if your goal is to master cybersecurity, lacking that fundamental understanding is a massive roadblock. I mean, you literally cannot secure what you don't understand.
It's a serious question. Before we can even think about diving into all those complex cybersecurity tools, things like Kali Linux or Nmap for network scanning or Wireshark for traffic analysis, we really have to understand the machine we're actually trying to protect. You can kind of treat this as the ultimate fix to your cybersecurity frustration, because instead of just memorizing a bunch of random commands to type into a terminal, we're going to build a solid mental model of the machine itself. And once you grasp this, learning how to hack or secure it becomes incredibly intuitive.
All right, let's jump right into Section 1, the 4 basic functions.
Okay, let's dive into this by stripping away all the jargon and complexity, and just looking at the core architecture. At its absolute most basic level, a computer is simply an electronic, programmable device. That's it. And no matter the size, every single device operates on these exact same core principles. From a massive hospital server that's coordinating thousands of patients, all the way down to the smartphone sitting in your pocket, they all follow the exact same rhythm: receiving, processing, storing, and producing.
Let's walk through this rhythm together. It always starts with input. That's receiving information from devices like a keyboard, a mouse, or, say, medical sensors in a digital health environment. Next comes processing, which is where the computer actually analyzes that incoming information. After that, we have storage, where the data is saved, either just temporarily or permanently. And finally, output, where the results are displayed back to you on a monitor or maybe played out through your speakers. Input, process, store, output. That right there is the heartbeat of literally every single computing device.
Moving on to Section 2, the hospital analogy.
To make these concepts really stick in your mind, I want you to think of a computer exactly like a bustling hospital, where every single department has a highly specific critical job to do. First up, we have the central processing unit, or the CPU. In our digital hospital, the CPU is the doctor. The doctor thinks, diagnoses, calculates, and makes the big decisions. So when you search for a patient record, the CPU is the doctor who processes that request, runs the query, and determines exactly what needs to happen next. Every single thing the computer thinks through happens right here.
Next up is RAM, which stands for Random Access Memory. You can think of RAM as your temporary working memory. In our hospital, RAM is the nurse holding today's patient chart. That nurse needs the chart for immediate, lightning-fast access right now, while they're actively working with the patient. But, and this is key, it only holds what is actively being worked on at this exact moment in time.
But what happens when that patient goes home? The nurse doesn't just keep carrying their chart around forever, right? It goes to storage. Storage is the permanent memory, functioning exactly like a hospital's basement archive. It keeps all those records safely and securely over the long term. Even if the power goes out or the hospital totally closes down for the night, those records are going to remain perfectly intact down in the archive.
Now let's take a look at the NIC, the Network Interface Card. The NIC handles all the communication with the outside world. It acts exactly like the hospital reception desk. If any information needs to enter or leave the hospital, it has to go through the receptionist. And in cybersecurity, understanding this is absolutely vital. When we use tools like Wireshark to capture network traffic, we are essentially pulling up a chair at this reception desk, monitoring every single packet of data coming in and going out.
Which brings us to Section 3, Hardware versus Software.
We really need to clarify the difference between the tangible and the intangible parts of this whole ecosystem. Really, it boils down to one simple separation: hardware versus software. Hardware consists of the physical parts you can actually touch with your hands, so the monitor, the keyboard, the physical CPU chip itself. Software, on the other hand, consists of the intangible programs, things like Windows, Linux, or a digital health system like OpenMRS. To frame this beautifully, think of it like this. Hardware is the human body, and software is the human mind. The software needs the physical body to act, and the hardware absolutely needs the software to tell it what to do.
So the really crucial point here is understanding how these pieces interact, particularly when it comes to memory. Let's clear up a super common confusion right now. Think of RAM as the physical size of your desk. If you open a web browser with 50 tabs open, a heavy cybersecurity tool like Burp Suite, and a huge Word document all at once, your desk gets incredibly cluttered. Your computer starts slowing down, not because it's broken, but because the RAM, your temporary desk space, has simply run out of room.
And holding all of this physical hardware together is the motherboard. It acts as the physical hospital building itself. It provides the necessary pathways and the structural foundation. Without the motherboard, literally none of these incredibly powerful components could talk to each other. The doctor, the nurse, and the archive would all be totally stranded in separate dimensions.
All right, let's look at Section 4, the Operating System Manager.
So, now that we've got a really solid grasp of the physical building blocks, how is all of this actually controlled day to day? Enter the operating system. Just like a hospital manager coordinates the staff to make sure they aren't bumping into each other and are working as efficiently as possible, the operating system coordinates all the computer's components. Whether you're running Linux, Windows, or macOS, its fundamental job is to manage the CPU, allocate the RAM, and organize the storage.
And this brilliantly illustrates how everything is layered. Notice the 3 layers here. Up at the top, you have your applications. These are your programs like Word or Wireshark. Down at the bottom, you have the raw hardware. Here's the big takeaway. Applications never talk directly to the hardware, ever. The operating system always sits right there in the middle as the ultimate mediator. When an application wants to save a file, it asks the operating system, and then the operating system goes and talks to the storage drive.
And finally, Section 5, your cybersecurity toolbox.
Okay, we've built our hospital, we've hired the staff, and we have our manager in place. Let's bring this directly back to those security tools you are so eager to learn. In cybersecurity, you are constantly going to hear about Kali Linux. So based on what we've just covered, what actually is it? Well, it's simply an operating system. It's a hospital manager. But it's one that's packed with a highly specialized medical toolbox of pre-installed security programs. Nmap, Wireshark, Burp Suite, Metasploit, OpenVAS. But here is the secret. Every single one of those advanced tools relies entirely on the basic hardware functions we just learned about. Wireshark is just an application using the NIC to listen. Nmap is just an application using the CPU to calculate network paths.
By taking the time to really understand the machine, you are no longer just memorizing tools, you're mastering the environment. You know how the doctor thinks, you know how the nurse holds the data, and you know how the receptionist talks to the outside world. So now that you understand exactly how this digital hospital operates, from the physical hardware all the way up to the operating system, which part of the network are you ready to secure first? The foundation is laid, so the real fun begins now. Keep exploring, and I'll catch you in our next explainer.